Hello students, in this lecture we shall do some numericals on the basis of ideal gas equation. And first question is how large a balloon can be filled with 2 gram of helium gas at 27 degrees Celsius and 380 millimeter Hg of pressure. This is pressure and this is temperature and this is weight of helium gas and how large a balloon. This means we have to calculate volume. Now we know that ideal gas equation is equal to PV is equal to nRT. Here P is pressure 380 millimeter and it should be converted into atmospheric pressure. Then we divide it by 760 and this is equal to 1 by 2 atmospheric. Okay, volume we have to calculate, and how can then this n can be calculated as n is equal to weight by molar mass. Weight is 2 gram and molar mass of helium gas is 4, then it is 2. Then we put in the equation, the values can be put, and here temperature is T is equal to 27 degrees Celsius, which can be, if we convert it into Kelvin, then 27 plus 273 is equal to 300 Kelvin. Now PV is equal to nRT, we have to calculate V. V is equal to nRT divided by P, and that will be equal to number of moles is equal to 1 by 2. R, value of R, gas constant, it is equal to R is equal to gas constant is equal to 0.0821 liter atmospheric per Kelvin per mole. So value of R is taken as 0.082 and T is temperature is 300 Kelvin and divided by P, pressure is 1 by 2. So it comes out to be, if we calculate it, we get 2 cancels out 2 and it is 0.82 into 300 and that is 24.63 liters. So this is the answer. Volume of the balloon that can be filled with 2 gram of helium gas at 27 degrees Celsius and 380 millimeter Hg is 24.63 liters. Now we come on to the second question, that is a gas has volume 300 milliliter at 27 degrees C and 480 millimeter of pressure. What will be its volume at STP? See, P1 is equal to, here we can see that PV divided by T is equal to constant, and in this way P1 V1 is equal divided by T1 is equal to P2 V2 divided by T2. Here P1 is equal to 300 ml, and if we convert it into liter, then it is 300 divided by 1000 liter. And V1, sorry, this is V1. V1 is equal to 300 m, and P1 is equal to 480 millimeter pressure. 480 millimeter. Now we convert into atmospheric, and it will be 480 divided by 760. Pressure. Atmospheric pressure. And T1 is equal to 27 degrees C, and we convert it into Kelvin, and that would be 27 plus 273, 300 Kelvin. And now we come on to V2. This is to be calculated, and P2 1 atmospheric, and T2 is equal to 273 Kelvin. Now we put these values in this formula, and we can calculate it V2. P1 is 480 divided by 760 into V1 300 divided by 1000 divided by T1 into 1 by 300. This is equal to 1 divided by 273 V2, and V2 can be calculated. It comes here, it is 273. If we calculate it, we can get that V2 is nearly 170, 0.172 liter. If we convert it to milliliter, it is 172 milliliter. So this is the volume, which at volume of the gas at STP. So this question is done this way. Now we come on to the third question, that is calculate the temperature at which we have to calculate temperature at which 35 gram of nitrogen occupies a volume of 10 liter at 2.5 atmospheric pressure. Now W is equal to weight of gas is 35 gram, and molar mass of nitrogen is 28. 14 plus 14, 28. Pressure is 2.5 atmospheric, and volume is 10 liter. Now we have to calculate T. See, PV is equal to nRT. PV is equal to W by M RT. P is 2.5, V is 10 liter, and is equal to W is 35 gram, 28 molar mass, R is 0.082 and T is to be calculated. So we get T is equal to 2.5 into 10 into 28 divided by 35 into 0.082, and if we calculate it we get 243.9 Kelvin. So this is the temperature at which 35 gram of nitrogen and occupies a volume of 10 liter at this much of pressure. So now we come on to the fourth question, that is how many moles in 800 milliliter of a gas at pressure 500 milliliter and temperature at 50 degrees C. So we have to calculate number of moles. Here P is equal to 500 millimeter and we have to convert it into atmospheric pressure, then it is 500 760 atmospheric, because in 1 atmospheric pressure 760 millimeter pressure is equivalent to 1 atmospheric pressure. So for converting into millimeter into atmospheric pressure, we divide the value by 760. Now P is equal to this much. R is, we know R is 0.082 liter atmospheric per Kelvin per mole. This is the value of R, and V is 800 and we convert it into liter, then it is 1000 liter, which is equal to 8 by 10 liter, and temperature is 50 degree, 50 plus 273 Celsius is converted into Kelvin, and this comes 323. Now if we calculate it, we will get, we have to calculate number of moles. N is equal to PV divided by RT. Then P is equal to this 50 divided by 76 and V is equal to 8 by 10 and PV divided by RT. Divided by 0.082 into 323. This is R and this is T. If we calculate it, we get that number of moles is equal to 0.0198 moles of the gas is present in 800 milliliter at this much of pressure and at this much of temperature. So these are the some of the numericals to get you an idea of how these numericals are calculated on the basis of ideal gas equation.